Okay. Today we are going to continue the exercises as I told you. But before this, let's look at what we learned last week first. Wait, I'm looking for. Wait, never mind. We go to here, resolution. Okay, now when we got one force here, right? When we got one force here, if I bring it down, right? I bring it down. If I touch the theta, I use cos. Not touching, I use sine. All right. Some of the students they memorize it this way. Fx is cos, Fy is sine. No, not this way. So you have to see whether it is touched theta or not. Touch, then cos. Not touching, then sine. Okay, remember that. So today we are going to continue the exercises. Not many of you do it, right? But never mind. I'll discuss all the objective. Try lah. Within 2 hours. Alright. If I cannot finish, then the rest one, I'll skip it. Alright. So okay. So we quickly go to here. Diagram 15 shows the lot with the weight W that is been equilibrium by 2 string. So now here you need to know how to draw. Alright, you need to know how to draw. So first of all, the weight is going down. Weight is going down. Okay, weight is going down. We look at this. Weight is going down. Correct. Weight is going down. Yes, correct. Weight is going down. Yes, correct. Weight is going down. Yes, all correct. T1 is going this way. T1 is going this way. Correct. T1, salah. This one salah. T1 going this way. Salah. Right. So, I mean wrong. This one wrong. Right. T1 is going this way. Yeah, correct. Now T2 going to the right. T2 going to the right. T2 going to the right. Yeah. A and D are both correct. Both correct. So we have to see the angle. So how to find the angle? Z. Okay. It means here it is 60. Mean the vertical and the T1. Vertical and T1 is 60. This one is 60. Right? Or this one is 60. Vertical is W. Vertical and T1. In between them, it is 60. Right? So in between them, W and T is 60. 60. Right? So this angle should be 60. This angle should be 60. So this one is correct. This one is wrong. You need to know. Alright, if all the direction it is the same, you have to see the angle. Alright. If you got question, please ask. If you got question. Alright. So this one is, which of the vector diagram represent T1, T2, and W? Alright. T1, T2. Alright, look at T1. T1 going to the right. T1 go 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 to the right. Okay. T2 left, and left. Okay, all correct. W that is going down. W is going down. So this one no. This one yeah correct. This one yeah correct. This one no. Alright. So left B and C. Left B and C. So we have to find the angle between them. So now here Z. Here it is 60. The T1 to the horizontal is 60. Right? T1 to the horizontal is 60. So this one is 60. T1 to the horizontal. T1 to the horizontal is 60 here. T2 to the horizontal also 60. Right? T2 to we do T1 first. Right? T1 is 60. Z. Here it is 60. T2 to the horizontal it is 60. T2 to the horizontal is 60. T2 to the horizontal it is 60. So this one 60. 60, 120. Yeah. But this one is 60. No, it is not correct. Because of T1 to T2. This one is 60. This one is supposed to be 60. So this whole thing already 60. So answer is B. Answer is B. All right. If you got question, please ask. Now, diagram 13 shows a wooden box moving to the rough surface when pulling with a force of 150 Newton. The frictional force is 15. They label everything for you already. So what we do is, what is the resultant force? What is the resultant force? 150. It is pulling here. So I bring here touch or not touching 40. Touch. Then I use cos. Right. So this is the force that stop the box moving forward. So this is frictional force, right? So what we have is, right, they want resultant force. They don't want to calculate acceleration. So the resultant force is 150 cos 40 minus 15. Right, this is your resultant force. If they want acceleration, you need to find, you need to put MA is equals to this. Okay, so 150 cos 40 minus 15. So how much is this? 99.9. So answer is 99. 99.91 here. Alright. Unit is Newton. Okay. Answer it is D. So we do this. Diagram 14 shows the block slide down to the frictionless plane. What is frictionless plane? Frictionless plane, it is the plane here, it is smooth, no friction. Alright. So the anchor is theta. So we label all the force first. Alright, this is W. This is R. Okay. Cannot see. I put it to here so that we can see it. I put it to here so that you can see it. So we got an anchor here. This is theta. Alright. So here it is theta. Okay, so we put everything in already. If the gravitational force is G, what is the acceleration? So this one is, I don't want to put W already. I put it as G because they say it is gravitational G only. Alright, so I put it as G. So now I am going to bring this force W. Right, W you bring to here. Right, W you bring to here. Touch or not touch this theta. Touch or not touch this theta. W I bring to here. Because this one, it is going to bring it down. Right? They don't want to find the error. So W, right, G, bring to here. Right? It is G sine theta minus the friction. No friction. 0. So G sine theta. So answer is G sine theta. Not touching. Not touching theta. If you are still not good in touching or not touching, you have to practice more. Right. Now, the diagram shows a housewife cleaning the floor. So what is the forward force? Now I want to find the forward force. Forward force is the force that, this is the force that you apply. Forward force is here. Right? This is downward force, Fy. This is forward force. Forward force, touch or not touching? Touch or not touch theta? Touch or not touching? Not touching, right? Not touching, you use sign. Not touching, you use sign. But you find here that is no answer. Fx is F sine theta. Cannot. Cannot write theta. I have to use the formula. Forward force is F sine theta, right? But we don't have it. You see, A, F cos theta, tangent theta. So, so now this one is, we know that this one, it is 90 degree, right? This one is theta. So how much is this? Right? How much is this? 90 minus this. 90 minus theta. 90 minus theta is here. So what happened if I bring this one to here, touch 90 minus theta or not? Touch or not? Touch, right? So touch, then we use cos. So F cos 90 minus theta. F cos 90 minus theta. So answer it is C. Answer it is C. So this one also equivalent to F cos 90 minus theta. If you learn in at maths, right, trigonometry, so you will learn, right? You will learn this, huh? Alright, cos theta is equals to sine 90 minus theta. Right? You will learn it. Sine theta is equals to cos 90 minus theta. Right? If you know. If you learn in trigonometry, you will learn this. Right? Okay. And maths, huh? So an object that is in equilibrium when acceleration 0, yes. Stationary, yes. Uniform velocity, yes. Resultant force 0, yes. All of the above. Right, this one is correct. Right, equilibrium, all of this one is correct. Now, calculate the horizontal force. All right, horizontal force. Horizontal force here, it is 1,000. 1,000, not 1,000. 10,000, sorry. 10,000. Now, touch or not touching. Horizontal mean Fx. Horizontal touch, right? Touch, then we use cos. Right? Touch, then we use cos. So this one is Fx is horizontal is x. 10,000 cos 55. Right? 10,000 cos 55. 10,000 cos 55. Answer 5,700. 5,736. 5,736. Yeah. Alright, round off. Unit is Newton. Right? Unit is Newton. Touch, then cos. Not touching sign. So very fast, very easy. Okay. So this one is T1 and T2. Alright. So the T1 is in this direction. T2 it is in this direction. This is W. Okay. So we try to see W going down. So this one wrong. W going down. This one wrong. W going down. Yeah. W going down. Yes. These both are correct. So I mean, this one is correct. This one is correct. So this one wrong. This one wrong. T1 going this way. T1 going this way. This one salah. T1 going this way. Yeah, correct. T2 going this way. T2 going this way. Yeah, correct. So answer is D. Very easy. You just look at the direction, then you will get it. If the direction all correct, then you try to look at the angle. So this one, no angle. So definitely the direction will give you the answer. Alright. Diagram 17 shows the stationary object with weight 150. Okay, we put it in 150 here. W is 150. Alright. So now two rod possessing tension T1 and T2 respectively. T1 and T2. So here got 40 degree. So I zig. Here will be 40 degree. So this one will be 40 degree. Alright. So now calculate T1 only. Alright. So T1 only. So I need to write the equation. T1 bring to here is T2. Right? T1 bring to here. Touch or not touching 40? touch, then we use cos. T1 cos 40. T1 cos 40 is equals to T2. I got two unknown, cannot do. Leave it as 1. So I want to write the second equation. Second equation is T1. I bring it up to here. Touch 40 or not touching 40. Alright, don't look at this 40, yeah. Look at this red one. So T1, touch or not touching 40. Not touching, I use sign. Right? Is equals to the weight. Now how about this one? This one is not contributing to up and down. It is just go to the right. Now if teacher I want T2 cos touch 90. Cos 90 it is, you press calculator, T2 cos 90. Cos 90 is 0. It is not contribute up or down. Alright, so this one bring to up only. Okay. Alright. So again, one more time. T1 bring to here, not touching 40. Sine 40 is equals to 150. T1 sine 40 is equals to 150. Right? This is the second equation. So you can find from here T1 how much. Alright. So T1 is 150 divided by sine 40. 150 divided by sine 40. So I'll get 233.36. Unit Newton. So they never asked me to find T2, then I just leave it here. Alright. I hope you can understand. Alright. Next one. Diagram 14 shows the poster hang on the library with the string and the nail. The weight of the poster is 12 Newton. Alright, so this one is 12 Newton. Find the T. Right, T cos 35 is equal to T cos 35. As I told you, this one and this one, it is the same. You don't need to go to the horizontal. No need. So the thing that I want right now, it is go up. T sine 35 plus T sine 35. Teacher, these two T same or not? Same. Why? The angle, it is the same. So the T will be the same. The one that go up plus the one that go up is this equals to the weight. So T sine 35 plus T sine 35 is equal to 12. Right? So this sine 35 plus sine 35, you factorize. Okay? So you bring it down. Okay? So sine 35 times 2. Sine 35 equal I times 2. Right? Times 2 is this one. So I bring down. So 12 divided by answer. Or you inverse then times 12 also can. Right? Up to you. Not 10.46. So T is 10.46. Unit Newton. Very fast. You use this way very, very fast. You don't need to draw triangle unless they ask you to draw. Right? Normally in objective, they ask you to draw the triangle. You also follow the direction what for you draw. Alright. So unless they really ask you to do in structural question, we are going to see it later. Okay. Now that is a flag erected on the top hilltop. So what is the force do? How much is the force does the pole exerted onto the ground? Exert on to the ground. Exert on the ground. What does that mean? Right? Exert on the ground means you pull here. Right? You want to go to the ground. Okay? This force here, you want to exert on the ground. This force here, how much is this onto the ground? Right? So we got two forces here. 100, 100. So this one you bring to here. Touch or not touching? Touch the T. So this one also touch the T. Right? So 100 cos 30 plus 100 cos 30. So total force is plus 100 cos 30. Right? 100 cos 30 plus 100 cos 30 is 100 cos 30 at time 2. So I'll get 173.2. 173.2 Newton. Right? Exerted on the ground. So I see your answer here. Like, you see, you use sine. What is mean by sine? Right? So if you are using sine, what does that mean? The sine mean sine, you bring to here, not touching. So this is not exerted to the ground. Alright? So this one is wrong. So here they said exert on the ground. So meaning that you are bringing this force to here. Wrong. So should be cos 30, not sine 30. Alright? Okay. Alright, so we are going to do this. Which equation it is correct? So I label all the force first. This is theta. Right, theta, put it in. Now here T cos theta is equals to F. Right? So T cos theta is equals to F. T cos theta is equals to F. Alright. So T is equals to F. T cos theta is equals to F. Yeah, correct. Alright. Okay. So I got the first one. Now second one is number 3. It is correct. So now I want to bring this force upward. T sine theta is equals to W. T sine theta is equals to W. T sine theta is W. T sine theta is W. Don't have. Right? T sine theta is W. So I got number 3 only. Number 3 only. Number 3 only. T sine theta is W. This one is wrong. So answer is number 3. So number 3 is correct. Number 3 is correct. So 1, 3 or 1, 4. 4 is definitely wrong. So the only one thing is left 1. So answer is B. You have to put B. But this one, not so right. I don't know whether you have learned this one in your maths or not. Do you learn this one in your maths? Vector. Do you learn this one in your maths? Vector. So in vector, we got one way to write it. So this one, if they write it this way, T vector T plus vector F plus vector W, it is 0, mean equilibrium. So in this one put to here, this one put to here, and this one put to here, mean it is correct. But this one don't have symbol. So no symbol, we are going to think this one it is a magnitude only. But in vector, this one is correct because vector has direction. Vector has this direction and this direction and this direction. You learn vector, so number 1 can if got this one. So I am going to put in here and here. Actually, you can write it this way, like T, like that. F, like that. W, like that. Or like that also can. Alright, up to you. Alright, you learn in math, okay. I put it in this way, then okay already. So I will put answer as B. This one salah. W is salah. T cos theta. You see, you do this, huh? T cos theta. T sin theta, right? T sin theta. This theta. T not touching theta is equals to W. T sin theta, right? T cos theta is equals to F. All right. That's why this one you get wrong. No, I should not see here. Now, a cat is sleeping. Sleeping means not moving lah. Not moving. So, this one is theta. So, their theta is not drawing well. Their theta, they put it into this here. Theta here. So, we just know lah, this theta is here lah. Alright? So, now what happened is, W, I bring to here. Alright? So, I haven't labeled this yet. This is theta. Okay. W bring to here. Right? W touch theta. W cos theta is R. W cos theta is equals to R. So R is equal to W cos theta. I see R is equal to W cos theta, R equals to W sin theta. Alright, these two it is wrong. Okay, never mind. This one is wrong. We try to see into this direction. This one you bring to here, not touching theta, is equals to this, so that it is not moving. F is equals to W not touching theta. W sin theta. F equals W sin theta. F equals W sin theta. F equals W sin theta. Right? So answer is D. Alright, answer is D. Okay. What you do is correct. Very good. Okay. All right. Now, yeah, I want to ask you one very easy question later. All right. If I forget, do let me know. I want to take this as my example later. To let you understand better of what is this. Okay. Now let me explain this question first. Finish this question, then I will explain in detail what is R here. Okay, so now diagram C is the worker mopping the floor. Right? What is the magnitude of horizontal force Fx? If the pushing force of the worker on the mop it is 40 Newton, so this one is 40. This one it is 40. The pushing force it is 40. Alright. Now, yeah, what is the magnitude of the horizontal force? Horizontal force, alright? Touching 50. 40 here, touch 50. 40, touch 50. 40, cos 50. So Fx is 40 cos 50, right? 40 cos 50 answer. 40 cos 50. What do we have? 25.71. 25.71. Right? 25.7 will do. Okay. This is your answer. Horizontal force. Okay. Now, okay, I want to take this example. Okay. Now, here. For every action, That is pushing down with 40 Newton. So that is a reaction. So the one that going down is the one that going up. Okay. So how much is the R? Okay, I want to find how much is the R. R is 40 sine 50. Not touching 50, no, you bring down, you bring down, pressing down, right? So 40 sine 50. Okay, 30.6. Okay, so it is R is equals to 30.6. Yeah, 30.64. 30.64 Newton. 30.64 Newton. All right, this is you push, right? You are pushing to the ground, right? Because of you got one force going down, one force that going up, going to the right. So this mop, it is going to push forward. So, but you got one force that is pressing down, one force is pressing up. Okay, so how is the force drawing? So this one it is the force. All right. Now here this one is R, right? So this one is R. This is the force that pushing force, right, into this direction, right? And then no more, right? And here this is R, right? And this one is 50. So R is equals to 40 Newton sine 50. 40 Newton sine 50. R is equals to this value. Okay. Now, probably you still don't understand what I want to give you, but never mind. Let me give another example. Now, your mother is asking you, hey boy, help me to mop the floor. Okay. You nego with your mother. Alright. Mami, tired right? You know lah, ang pao sikit lah. Okay. Your mom said, okay. Mop the floor, and then I'll give you 10 ringgit. Okay. Then you go. So now you go do your work. Alright. You got two ways to do it. One is push. One is pull. Right. So push. You tired when you push what do you think? You should push or you should pull? You should push the mop or you should pull? Answer me. I want to see your idea. Whether you should push the mop your mother asked you to do. You should push the mop to mop the floor, or you should pull. Right? You pull. You pull. Push or pull? What do you think? ringgit. Your mother gotta pay you. 10 ringgit. You should push or pull. No one answering me. Pull in this way. Okay. Push, Okay, you said push, So how about others? Now, reaction always onto the ground, right? Alright, this one is the weight. This one is the weight. So here we don't take about the weight. We don't take about the weight. You know. So now what happened is here also 50 degree. Here also 50 degree. Okay. So this is the weight lah. So now this force is 40 Newton, right? 40 Newton, push it upward. This is R. Okay. So R plus 40. Now touch 50. Cos 50 is equals to your W. Okay. So you bring this one down, right? You bring this one to here. R is equals to, so this one don't have, so I bring to here. So let's say got lah. I don't have any W here. Let's say it is 20 Newton lah. Whatever. 20 minus minus 40 cos 50. Oh, I takut it is negative answer. Hopefully no lah. 20 minus 40 cos 50. So what do I have? Negative answer. I don't want. Let's say the weight it is 40 lah. Okay, 40 lah. I put it as 40. Weight is 40 ah. 40 minus 40 cos 50. So what do you have? You got 25.7. 25.7 Newton. How about this one? This one I want to add in the weight because of this one also got weight So I add in the weight. The weight is going down, as I told you it is 40. Alright. So the one that going down is the one that is going up, it is R. The one that going down, it is 40 plus this one cos or sine 50. This one not touching 50, sine 50. 40 sine 50. So you see the difference. You see the difference. Okay. This one is 40 minus 40 cos 50. I takut I press it wrongly. 14 only. Sorry, not 25. 14 only. 14.3 Newton. Okay. How about this? 40 plus 40 sine 50. You find that this one is 70 Newton. This one is your pushing force. This one is pulling force. You find that the pulling force, the R is so little only, 40 Newton. So you feel very easy to do it. You mop the floor very fast like you like pulling only. But if you are doing pushing, you feel very tired. Why? Because the force that you use, it is much more higher. Right? That's the difference. Pushing and pulling. Okay? Alright, we continue. This one is like vector also lah. Alright. T1 into this direction. T1, T2, and then W. Right? So now if vector T1 plus T2, right, plus W is equal to 0. Right? Equilibrium 0. Right? T1 plus T2 plus W is equal to 0. Answer is A. But they don't have vector. So we understand this one is using vector. Right? You have to see, if not, no answer. T1 is equal to T2 is equal to W. The angle, it is not the same. T1 plus T2. T1 sine something or cos something plus T2 sine something or cos something is equal to W. Right? So, not correct. Okay? Answer is A. Alright. We continue. Make it bigger. Diagram 15 shows a truck pulling a car with a piece of iron chain that make the angle of 60 to the horizontal. If the tension, it is 5,000. Right? This one is 5,000. Here it is 5,000. So what is the horizontal? Horizontal force is 5,000. Fx is equal to 5,000. You bring to here, touch or not touching. That's all. Touching 60. So cos 60. Cos 60. So 5,000 cos 60. 5,000 cos 60 should be 2,005. 2,500. Answer is A. Answer, it is A. All right. Now, the diagram 15 show Lina pushing the baby stroller, sorry, not trolley, stroller on the smooth floor. The force acting down is 70. So pushing here, it is 70. Constant velocity. Constant velocity means equilibrium. So what is the component move the baby forward? Forward means Fx. Fx. So F 70 touching 50 or not touching 50. Touching 50 or not touching 50. Not touching, we use sine. So 70 sine 50. 70 is F lah. F sine 50, M sine 50, F sine 50, M sine 50. Don't have. No answer. So no answer. We know here, this one it is, this angle here will be 40. So 70 touch 40. 70 cos 40 also can. 70 cos 40. Right? F cos 40. So answer it is C. Okay. Determine the horizontal force. F touch 50. At F is 60 at F cos 50. 60 s cos. 60 at cos. Answer is B. This one is supposed to be very easy. Calculate the tension of each drop. So these two, it is the same. The tension will be the same because they are T and T, right? So the force that going down, it is called weight, 1.5 kg. 1.5 times 10 is 1.5 times 9.81, sorry. So it is 14.715. Wait, alright. So now the force that going upward is T touch 65 or not touching 65. So if you don't draw it out, it is hard to see. Never mind, we draw it out. We draw it out here. So Z, inside here it is 65. Inside here it is 65 also. Too small so that I write it outside. Right. This one is inside here. This one also. Right. Here also. Both are this angle and this angle. So now here T, I touch 65 or not? Not touching. Not touching, I use sine. T sine 65 plus T sine 65 is equal to this. T sine 65 plus T sine 65 is equal to my 14.715. Okay, so T is sine 65 plus sine 65. Sine 65 times 2. Sine 65 times 2. 1.8. So 14.4. You inverse first. Answer here inverse first. You time 14.715 is your answer. 8.11. 8.12. Okay, 8.12. Okay, answer is A. Yeah, okay. All right. Should be okay now. Calculate the horizontal force. All right, 10,000 touch. Horizontal touch. All right, cos 10,000 cos 55. 10,000 cos 55. Right. Answer is 5,007. 5,007. Answer is A. So this one I don't write the working. I hope you know. Very easy. This one too easy. Right. T1, T2, and W. W that's going down. W is going down. W is going down. W is going down. T1. T1. Salah. So answer is D. T1, T2, T2. Alright. They label for you. Very good. Some question they don't label for you. Okay. Now W, oh correct. T1, T2. Okay. T2 going down, salah. T2 going this way, salah. T1 going this way, salah. So answer is A only. Very easy. Very easy. So we try to do some structural question. All right. Okay, I make it smaller. Okay. Now, diagram 8.1 shows a working pushing a wheelbarrow with the force F, right? F, pushing. The frictional force, it is FR. Okay, what is mean by resultant force? Resultant force is the vector sum of the two or more forces, right? That so what is it called? Resultant force is a single force. A single force represent the vector sum of two or more forces act on an object. Right, a single force represents the vector sum 2 or 3 or 4 forces. Normally it is 2 lah, right? So give the force F, it is 100 Newton. Calculate the horizontal force. All right, horizontal force is this one. F how much? 100. They said 100. F touch 60, cos 60. Right, F cos 60. So Fx is 100 cos 60. 100 cos 60 is 50 Newton. Put it back to this size. Okay, 50. Okay, good. All right, so we continue from here. 8.2 shows the structure of wheelbarrow. Okay, now you are required to modify so that can be done to the wheelbarrow so that the wheelbarrow can move easily forward. Now you want to move forward, your Fx have to be big. All right, your Fx have to be big so that it can move forward more. What does that mean? Okay, now I try anchor. So if this one is 20, if this one the anchor is 20, so let's say this one is let's say 100 lah. Okay, 100. Right, so 100 Newton. 100 Newton, you push it with 100 Newton into this direction. So how much you will contribute to the right? So contribute to the right is Fx. Fx is, this one is 20, let's say, let's say. So it is 100 cos 20. Right, how much it is? We calculate. 20. Okay, so you got 94, about 94 lah. I said 94. 94 Newton, it is pushing forward. Okay, I'm not happy with this. I want to try. Fx, what if this one is 30? You angkat more, right? You pull up, you carry up more. So the angle will be bigger. So 100 cos 30. So cos 30, it will be 86 only. 87. Okay, I round off, never mind. All right, this number at the back, not important. Right? So how about 40? I change this angle. I carry more upward. So carry more upward, it make you harder to move. right? So 100 cos 40, right? So I change this number to 40. I do 3 examples here. So it is 76, 77. Pushing forward, pushing forward, pushing forward. So the angle of the theta have to be big or small so the wheelbarrow can easily move forward faster. What do you think? What do you think? The angle have to be big or small? The angle have to be big or small so that it can move faster, more force forward. So answer is bigger angle or smaller angle? Not sure. I used calculation for you already. Right? The angle have to be smaller angle of theta. Smaller than theta. Right? Smaller angle of theta. Why? Why? So more forward force. Produce more forward force. Right? More forward force. Right? If you pull up higher, so more vertical force, less forward force. Is that okay? So now teacher must be a smaller angle. So you depend on what angle they are giving you. Sometimes they will say, oh, not this angle. They'll give you this angle. So you have to see. You have to see. Okay. Length. So this one have to be long or short, right? Long or short. So this one have to be long. Longer handle, right? Oh, okay. No problem. No problem. All right. Your internet got problem, but never mind. You just if you don't understand, you pull backward and then watch until you understand. So probably my that one finish already. You still at behind, but no problem. As I understand one. You must understand then okay already. Longer handle. Why longer handle? So this one is about moment. Let's see how you answer. Can handle the lawnmower? No. This one is it produce higher moment. But moment you are not learning. Only from 6 you will learn. Right? Higher moment. Moment is one kind of force. What is moment? Moment is F. You are okay leh? You're like not very far. I thought you are 5 minutes or 10 minutes lagging. So moment is moment force. Moment is one kind of force. Is the force time the length. Force time the length. Higher moment. Because of I'm not sure what is the answer, so we try to see the answer better. SBP 2024. SBP earning. I want to see what do they give. Question number 8. Smaller anchor, yeah. Larger horizontal force, all right. Fx is larger, resultant force will be increased. They said, right. More forward force, okay. More Fx, right? More Fx. Fx is larger, more forward force, same. Longer, why? So angle of theta is decreased. Fx is larger, right? Okay. Acceleration increase, forward resultant force increase. So you can just simply write one. Because of moment is not in form 5, so I should not put in moment. So I just said Fx is larger forward force. right? Larger fx. Now density, low density, so that it is like the right, like the low density, right, like the mass decrease, acceleration increase, up to you, right? Okay. Is that okay for you? Larger angle wrong, so increase the vertical component mean you press down more, so press down more. Okay, you want to move forward. Okay, now diagram 6.1 6.2 shows the picture frame that is a force in equilibrium. Okay, 40 degree, 20 degree, right? 2.2, this is 4, right? This is 4, this is 0.3 kg, this is 0.3 kg. What is mean by force in equilibrium? Force in equilibrium mean net force or resultant force, right? Resultant force act on the object is equal to 0, right? Resultant force act on the object is equal to 0. Now compare the angle. This angle and this angle. So 6.1 more than 6.2, right? The tension 2.24, 6.2 more than 6.1. Okay. Weight 0.3 kg, 0.3 kg, 3 kg, so same. 6.1 is equal to 6.2 lah. Alright, you can write 6.1 is equals to 6.2. Based on the relationship of the angle, and give me the relationship of the angle with the tension T, right? So the greater the angle, right, the smaller the tension, right? When the angle theta increase, right, the tension of the string decrease or smaller. When the theta angle theta, you better put it in because they put it in also, right? You comma then comma lah. I didn't comma, I forgot to comma, but never mind, leave it. Leave it. When the theta angle theta increase, the tension of the string decrease. Based on the observations B and C, make a conclusion about the appropriate method of hanging the picture frame to prevent the string from breaking. So if the tension too high, then it can break. So the anchor must be big so that the tension will be smaller. Okay. Use higher angle theta, right, to hang the picture frame. Forgot to comma. Now I comma. Use higher theta, use higher angle theta to hang the picture, right? Okay. Now, if the picture frame in 6.1 is replaced with same size of picture frame and mass is 0.5 kg, calculate the tension, right? So now this one it is 0.5, right? Here is 0.5. So now this is T, this is T, right? I calculate here, later I bring it down, right? So T, you touch. You don't need to bring left and right already because left and right will cancel each other. So you bring up only, right? T, I bring up to here. T, I bring up to here is equals to the W. Okay? So T sine 40 plus T sine 40 is equals to the W. W is 0 0.5. They said replace with the 0 0.5. 0 0.5 multiplied by 9.81. Wait. Okay. So you got the T as sine 40 times 2. Sine 40 times 2. Right? Is here. I bring down. So I inverse times 0.5 times 9.81. That's my answer. Oops. 1.29. 1.2 at 6. 1.2 at 6. Unit Newton. So even smaller. Impossible leh. Higher. Should be bigger leh. Bigger than 2.2 leh. What do I do? Wait I press one more time. Sine 40 plus sine 40. Sine 40 times 2 equal, I inverse. Inverse, and then I time 0.5. Time 0.5 times 9.81. 3.81. I pressed wrong just now. 3.81. So more than this. 3.815. Should be more. Cannot be less one. Cannot be less one. 3.815. 3.815 Newton. Cut. Pass. Okay. Alright, I check the answer. Erling Sun. SA 2023. SAKB. Schema. Question number 6. 6.1 more than 6.2. 6.2 more than 6.1. 6.1 equal to 6.2. Net force. This one, net force or resultant force are up to you. Right? Sometimes I get used to write net force. So net force it is correct one. Resultant force and net force it is the same. Right? Net force is equal to 0. Okay? Like but this chapter we all use resultant force, so we use resultant force, right? But you write net force, it is okay one. Right, I told you okay. 3.815, yeah, correct. Okay. Anchor increase, T decrease, right? Anchor increase, T decrease. Anchor increase, T decrease. Okay. Yeah, no problem. The larger anchor. Use higher angle to hang the picture. Okay. All right. Okay. We are going to continue, but before we continue, we rest for like 5 minutes. All right, like usual. About 8:30, I'll let you to rest for a little while. We are going to continue later. If you feel like, teacher, I don't want to rest, you can try to do number 7. We got a lot of question here. A lot. So I just pick up some. Later I'll pick up some. But since now we are going to try to do all correct. This one is correct. You can do. Later, if I cannot finish, like 9:30 still cannot finish, then I'll pick up some Like this kind of question, it is kind of harder I'll mark for you. If you do I'll mark for you. But this one, because you ask me in Mandarin, so I'll answer in Mandarin for you You have to put in angle all this All right, you try to do after 5 minutes. We are going to continue again. I'll see you later. Alright, I'm back. Alright, so we continue. We continue, So, diagram 7.1 shows a worker cleaning the floor with the mop. The force act on the mop, it is labeled as F50 Newton. Sketch the resolution of force acting on the mop into two components, right? So, one is Fy, one is Fx. Okay, now calculate the magnetic of vertical, magnetic of vertical and horizontal if the angle is 65. So this angle is 65. So Fx, they say Fy first, alright? I put Fy first. Fy is equivalent to, now here, Fy is 50. Now, touch or not touch 65, this angle is 65. They said that theta is 65. Not touching 65. Not touching 65. So I use sine. 50 sine 65. So I'll get 45.315. Unit Newton. So now I want to find Fx. Fx is now here 50. I touch this 65. Touch 65. Touch, I use cos. Right. So 50 cos 65. 50 cos 65. 21.131 unit Newton. All right, so 2 marks only. Okay, yeah, correct. Because I have marked this one for you already. So, what is the meaning of resolution of force? Resolution of force is a single force. It is resolute into, I should not use resolute. A single force that you are going to split into two components, right? A single force is split into two components of force, which is Fx and Fy. Okay. Resolving should not use split. Resolving into a force with two components, not split. Is resolving better. Yeah, I forgot this word. Okay, now here the characteristic of PQR here. Now type of the surface, all right? Type of the surface. Type of surface, it is smooth or rough. It's smooth, so easy to go down, right? If rough, very hard to go down, right? So it is smooth, right? Reduce the friction. Smooth, right? Reduce friction. Now, angle of inclination. So now if this one it is like that, okay, you slide down into this way. Wow, so dangerous. So I think, but if it is long, then slow. So this one it is play in the playground, so it should be more safe. Safety is more important. So I think should be smaller. Smaller. 10 degree like so. 10 degree like that only. 35. I'm not sure 10 or 35. If 10 like so slow. Smooth, 10 or 35. What do you think? 10 or 35? 35. This one is like 45. 35, I think it is quite okay. 35, it is quite okay. So the angle have to be small. You don't need to answer 10 or 35. Smaller angle. Alright. So to reduce the speed of the hits to slide down, right? To reduce the speed, so it won't be that fast. So for me, I think I'll choose arrow. But I know the answer is P already. You're not mistaken. Answer is P. Answer is P. But I think 35 is quite okay. But I already saw small, say small, so I put it as P. I want to put arrow one, right? P. Right? The most suitable slide it is P, right? Because the angle it is small. So this one mark only. You don't need to repeat. You don't need to repeat this. Okay. This question it is kind of hard. This question. That's why I see you cannot do this. Right? You don't know what to do at all. Right? If you draw the triangle, even get harder. So what is force in equilibrium? So I don't want to answer this already because we answered many times already. You copy from the front. Okay. Based on the diagram 2, sketch the vector diagram represent T1, T2, and FF frictional force. Okay. Acting on the vehicle. So now I am using T1 and then T2 and then FF. Right? Wait, one more time. T1, T2, and F. So the direction, put it in T1 and then T2 and then this direction here, FF, frictional force. Right. Now here we put in the angle, right? T1 to the horizontal. T1 to the horizontal. Here it is 20 degree. 20 degrees here. I use handwriting faster. This one, T2 to the horizontal. T2 to the horizontal, it is 40 degree. So this one you can calculate if you want. So you put it in, it is 180 minus 40 minus 20. Minus 60 is 120. Okay. Now calculate the T1 is frictional force is 950. So this one it is 950. So calculate the T1. So you can use sine rule. You can use sine rule. Now because of this one is triangle, I use the sine rule for you. Now T1 over sine 40 is equals to this one, right? 120. 120 over FF. FF is 950. Sorry, not one. 950 over sine 120. Okay, right? So you can get T1. How much is T1? $950 divided sine 120. 950 divided by sine 120 times sine 40. So how much will you get? 705.11. 705.11 unit Newton. Okay. Now, as I told you, I got another way for you, right? Okay, see how I do? This one it is, they said this one it is 950 Newton, right? So, T1 pull this side, T2 pull this side is equals to this one, right? Equilibrium, right? This one is equilibrium, right? You see, it go back one round. Okay. So what I have is T1 cos 20, T1 cos 20 plus T2 cos 40 is equals to 950. This is one equation. Now, the force that going up and down will be the same. T1 bring to here. I don't touch 20. Sine 20 is equals to T2 sine 40. Why sine 40? Because 40 I bring down, I don't touch 40. So T1 is equals to T2 sine 40 over sine 20. Or harder, oh. If I draw it out, easier. So I bring this one into here. So what I have is I want to find T1, right? Okay. Never mind. I should substitute T2, right? I substitute T2 because I want to find T1 only. T2 is equals to T1 sine 20 over sine 40. So I'm going to substitute T2 into here. Okay. So what do I have? T1 sine 20 divided by sine 40. Yeah. Times cos 40. Plus this one. T1 cos 20 is equal to 950. Right. T1 is I press this one first. Sine 20 times cos 40 divided by sine 40 plus cos 20. And then 950 divided by this. Alright, so I inverse times 950. I'll get 705.11. Right? You get back to the same thing. But seems like this one is harder because of you draw the triangle out already. You can use sine rule very easily. Right? If you use this way, also can. But if the question said hence, then you cannot use this. Hence means you have to use the diagram here. You get what I mean here? You use this one is much more easier. Now question. I don't know where to get wrong. You see T1 sine 70. 950. You have to use sine rule. You cannot use this. This is triangle for 90 degree only. Right? Let me see. Why do you get wrong? You should be doing this. T1 sine 70. T1 sine 70. T1 sine 70 is wrong. Wrong. This one is wrong. Okay. We continue from here. Diagram 2 shows the advertising board held with a light iron rod wire, a vertical wall of the building. Right here. The building is here. This is iron rod. So iron rod don't have tension. Alright. The iron rod is fixed, horizontal fixed. Right. Named F. F is called tension. Got wire tension. Alright. Draw the vertical force Fy of F on the diagram. Fy is the force here. Fx is the force here. I draw both for you. Right. The question only asks one. But I draw both. No lah. I don't draw both lah. I draw one only. They said draw Fy. So Fy, so already. This force is here, so you are going to pull to here. Now, if the mass of the here it is 50, the weight of the iron rod and the wire are ignored, calculate the F. So now here you got one weight, 50 kg, right? 50 kg, you change it to Newton first, right? So this one bring to here is equal to this one, so that the advertising board it is fixed there, not moving. Okay. Fy sine 30. Why not touching 30? Fy sine 30 is equals to weight. Weight is 50. Fy sine 30 is equals to the weight 50 mg. Right? Copy. Is equals to m is 50, g is 9.81. So now here Fy you can find already. Fy is 50 times 9.81 divided by sine 30. You will get 981. Unit Newton. Okay, 3 marks. So easy only like that only I go and check the answer 2021. Kedah. Question number 2. Oh, okay. They are using the weight 500 times 500 the weight, right? 500 times 10, right? So they previously they are using not 9.81, they are using G as 10. So if I use G as 10, okay, I am using G as 10. This one G as 10. Fy sine 30 is equal to 50 times 10 mg. Fy is 500 divided by sine 30. 500 divided by sine 30. How much will I get? 1000. So their answer is 1000 because of they are using G as 10. But now we are using 9.1. This one is 2021. 2021 sometime they still use some teacher they still use G as 10. Right? Okay. So we continue. Diagram 7.1, 7.1a and b shows the two identical photo frame with hanging on the wall with the same length, right? So this one 60, this one 45. So what is mean by equilibrium? Equilibrium, you know lah. Now, This kind of question I want to do. In the specs below, draw the triangle of force that act on the two frame 7A. This is T1, this is T1, this is W, right? Okay. So, T1, I start with W first, right? W and then T1 and T1, right? This angle should be the same lah, alright? I mean here, this one have to be like same lah. So label it, and then this one is weight. This one is T1. This one also T1. And the angle, put it in, right? This one how many mark? 2 mark only. 2 mark. Actually, if you don't want to put in, you really don't know how to do, you don't want to put in, it is okay. But in this structural question, I wish you can put in. Okay, T1 to the horizontal is 60. Right? So T1 to the horizontal, T1 to the horizontal is 60. T1 to the horizontal is 60. Z, 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 here 60, here also 60. So altogether here will be 120. Right? This one will be 120 degrees. So this 120 and then these two angle, it is the same because the T and T, it is the same. So this one will be 60 and this one will be 60. Put it in. So they got no way to minus your mark. Alright. Now, this one is T2, this one is T2, this is W. Okay. So I'm going to put it in. W first. Always W first. Easier. And then T2 and then T2. Right. So, this one is W. This is T2. This is T2. I double check with the direction. T2 going left, T2 going right. T2 going to the left, T2 going to the right. Weight is going down. Okay, weight is going down. Alright, should be okay. Now, the angle, I want to put in the angle 45. Where T2 to the horizontal is 45. T2 to the horizontal is 45. So, I put in the 45 and 45. T2 to the horizontal is 45. T2 to the horizontal is 45. Zigzag, zig. Here 45, here 45, here 45, here 45. 45 plus 45, 90. So, I'll get here as 90 degree. 90 degree, here divided by 2 will be 45. Here also 45. Okay. That's how you do it. Alright. Police 2021. Police. Okay. 30, 30, 120. So you can have another way to draw it. Alright, this way, or this way. Both are okay. Alright, both are okay. I told you before. Right? This, the weight is 20. I didn't put in 20. Got 20 or not? 2 kg. I didn't put in 20. Because now we are using 9.81. 2 times 9.81. You know lah. So I put in the W will be okay. I think should be okay lah. You want to put in 2 times 9.81, then you put in. Okay. Now next one. This question. You are required to determine the most suitable lawn mower to cut glass effectively. So now you got 2 ways to do it. One, it is pushing. One, it is pulling. Right? This is pushing. This is pulling. This is pulling. Now, like mopping the floor. Right? So this one is your lawnmower, the glass is at here. Alright, your lawnmower is hit here. So if you are pulling, so the force is little. The force is so little. If you are pushing, just now I do the calculation for you. then it will be more. So lawnmower must be pushing, not pulling. Right? Lawnmower. Now I give you, teacher, I told them lawnmower it is pushing, but there is other case, like you have to pull one. Right? Mopping, you have to push. Right? Now, what is the thing that you have to pull? Right? So now luggage. Your luggage is here. You are pushing your luggage, you feel very hard. You're not going to mop the floor. You are not going to use the luggage to clean the floor at the airport. No. What do? Is you want to go fast. You want it to be lighter. So if it is luggage, you are pulling your luggage, not pushing. All right. You have to identify what do you want. Right. Make sure you know what do you want. Right. So this one is pushing. So push is correct. Push is pull. Tolak. The direction is here. This one they write wrong. This one is not push. I guess you know, right? This one is salah. Yeah, I mean they both are push, but not this direction. Right? Push is this direction. This one is correct. Now you want more vertical force compressed down, so that the glass will be cut more effectively. So you have to cut the glass more. So the anchor have to be more. So if the anchor here less, right? Anchor here less, so you can try, right? Vertical force, right? You bring this one to here, right? You bring this one to here. See which one more force. This one you bring to here. Okay. So let's say this is 100 Newton, 100 Newton. So 100 sine 20. 100 sine 20. So how much is the force going down? 34. 100 sine 35. You find that this one is 57. This one is more force. Right? So answer is S. S is the answer. S is the answer. Alright. So what are they asking you? So the method of moving the lawnmower, pushing. This one I guess this one wrong. Should be pulling. Should I change it? No lah, I don't want to change it lah. Right? You know this one is pulling, this one is pulling, pushing. Right? Why? Pushing is more force acting downward. Okay. Size of the cutter blade. Alright. We look at the cutter blade. This is big. This one is small. This blade is big. This one is small. So this one is good. This one is good. Alright. Okay. This one is good. So larger blade. Larger blade. Larger. Larger size of cutter blade. Can cut more glass. The anchor have to be large anchor. Right? Between the horizontal line. So more force is compressed downward. More force. I don't want to write acting downward, same thing. Alright. If you want to write it as more force is acting downward, okay. More force compressed downward. Same thing. No worry. You rewrite this one will be okay one. Right. So we look at the answer. Here. This one push. Right, lawnmower is push. Okay, so it can cut more glass effectively. A larger blade can cut more glass. Right, larger angle to produce more force downward. Okay, same. Right, same. Is that okay for you? Let me see yours. This one you don't know, huh? When the anchor you didn't label, but this one is too much. I said it is okay. That's why I mark. Then I don't say your anchor is not putting. You didn't put in your anchor, right? Now push from left to right. What right to left? Push, then I'm okay lah. You said left to right, right to left. It is not that important. All right. Reduce the frictional force. You push or pull, reduce the friction. No, cannot reduce the frictional force. The frictional force is, let's say the ground, the rough surface, it is 20 Newton. So your frictional force is 20 Newton. Either you push or pull, it is still 20 Newton. Right? Increase vertical component what? Okay. This one like something hanging. Increase the vertical force. Increase the vertical component force. All right. You have to write it completely. Okay. All right. I want to see still got many or not. If many, I will skip some and then find the important one to do. Because left 20 minutes, I takut not enough time to finish all. Like all important more all important. This one also quite important. Right? This kind of question we haven't do. What is mean by frictional force? Frictional force is the force that against the movement of the object. Force against the movement of an object. Resist the moving of the object. So calculate the weight. Weight is equal to mg. Right? Now let me read. Diagram 2 shows a box 20 kg on the inclined plane. The frictional force is 100. This is 20 kg. Now, the plane. Okay, so this is W. W is 20 Newton times 9.1. But you know 2021, the answer might be 20 times 10, right? I see the answer is 20 times 10 or 20 times 9.1. Can or not? If not, later I need to change a lot. I see Sabah. Let me see Sabah. Sabah. Question number 2. Not this one. Sarawak. Sabah. Oh, Sabah no answer. Sabah no answer. Never mind. Sabah no answer. No answer, then you can use my own answer. 20 times 9.81, 196.2. Okay. 20 times 9.81. 196.2. Okay. Now, calculate the force that parallel, the resultant force parallel to the inclined plane. So the resultant force here will be, so I need to draw this angle first. This is 30 degree. Right? And then what I have is, this is 196.92. 196.92 bring to here, right? So parallel to the inclined plane, parallel to the inclined plane, 196.92 bring to here. Touch or not touch 30. Touch or not touch 30. Right? Not touching 30, I use sign minus 100. So the force will be equivalent to, 196 point, what again? 0.2 cos sine 30 minus 100. 196. Not enough leh, negative. This is negative. This is negative. Oh, you didn't cos. You didn't sine. Oh, I marked it wrongly. I didn't see it. My mistake. My mistake. Here. This one should be sine. My mistake. Okay. This one is negative. Cannot do. Right? Why? Because they are using they are using 10 here. Right? I changed it to 10. Right? So 200 Newton. So the F will be 200 sine 30 minus 100. 200 sine 30 minus 100, it is equivalent to 0. Let me try. 200 sine 30 minus 100 equal to 0. Right? So equal to 0. So meaning that based on your answer, what happened to the motion of the box? So the box will moving down with constant velocity. Right? Why? Because equilibrium. Resultant force 0. If just now you calculate like that, all right, nothing wrong. If you stick to your answer like this, all right, 19 something, 196.2. This one you get negative 1.8. Let's say lah, right? So the up is 196.2 cos 30. You see 196.2 sine 30 is 98.1. So the box is pulling down with 98.1 Newton. But you got friction 100 Newton. So the object will not moving. If you get this negative, you said the object is not moving. Because you pull 98, I pull up 100. How can it move? It cannot move. Right? It will not moving. Right? But if I put it at 0, 200, so this one will move with constant velocity. But your syllabus because of this one is 2021. Your new one all use 9.81. You no need to worry. You all use 9.81. Because of this one, I have to fulfill what they want. If not, this one negative so hard to so bad. You know what I mean? So I put it as 10. G as 10 here. Right, for this question. So yours one is all 9.81. Your gravity 9.81. Okay, next. What is mean by resultant force? I don't want to answer already. Now, using 11.1, 11.2, compare Wx, Fx, and angle theta. Wx. Yes, as stationary, right? Can this one either stationary or it can move down with constant velocity, also can, because it start to move, right? It can be stationary or it can be moving down with constant velocity. Also can, no worry. If just now you get this one negative, then you have to say stationary. If this one is 0, so it is either stationary or either constant velocity, both. Good, very good. Okay. Now, 11.1, 11.2, you got Wx, Fx, and angle theta. So, F we go and see each one. WX 125, WX 177. This is 30. This is R. This is, I don't know. Right. This is FG. Okay. So this is 30. This is 45. Okay, I got this. So compare the WX. WX 11.1. Right. WX, this one is bigger. In diagram, 11.2 greater than 11.1. Right, the first answer, they ask you to compare. Alright, second one, compare the FX. So now, what do we have is, I need to read this. This one's so long. Different acceleration. Right, different acceleration. Frictional force is Fg. Acting on the log at the both side, it is the same. Alright, Fg, it is the same. Alright, they said weight W is 250. Wx is the weight of the parallel. Okay. Resultant force is Wx minus Fg. Okay. Now, second one, compare the Fx. Fx and theta. Where is Fx? Oh, Fx. Oh, here. Yeah. Here is, let's say, I don't know how much. Let's say 100 lah. Let's say lah. Right, this one 100. They said both sides is the same. Fx is equal to this side 125 minus 100. This one is 177 minus 100. Of course, this one it is bigger than this one. Right. 11.2 is more than 11.1 because this one is fixed. I don't know how much, but it is fixed. But Fx for this one is greater than this one because of Wx is more. Alright. So Wx in Fx in diagram 11.2 greater than 11.1. Okay. Now theta, this one is greater than this one, right? Theta, I cannot write theta. In diagram 11.2 more than 11.1. All right, I put in the theta. Okay, next one. Relate the Fx with the theta. Right, Fx, the larger the theta, the larger the Fx. Okay, the larger the theta, the larger the Fx. The greater the theta, I cannot write the theta, the greater the Fx. The greater the angle theta. Put it in. The greater the angle theta, the greater the Fx. Next one. State a conclusion relationship between acceleration and the theta. The larger the angle, the larger the acceleration. Acceleration. The greater the theta, the greater the acceleration. Okay. 5 marks. 1, 2, 3, 4, 5. Yeah, 5 points here. 5 points here. All right. Next one. Diagram 11.3 shows a stationary block with smooth inclined plane when the P is applied to the horizontal on it. So W is the weight of the block and R is normal. So I am going to put it in since they are asking already. This is W. This is R. Okay, put it in. Do they say how much? No. And then angle here, this is alpha, right? So this is alpha. Alpha, yeah. Okay. Sketch and label the triangle. Sketch and label the triangle of force P, W, R. P and W and R, all this into this situation. So this one, it is you apply this force, it is going down. If you don't apply this, it's smooth, it will slide down. So you push here so that it is not moving. Right? So now I am going to label this one is equilibrium. Right? So W and then P and then R. Okay. So I am going to put it in. This is W. This is P. This is R. Alright, R into this direction. Okay, then alpha, put it in. Most of you will not put in the alpha. Alpha is weight to the R. Weight to the R. So this angle is alpha. This angle, it is alpha. Okay, format. Why it is format? I don't get it. Why it is format 2021 SBP. SBP kertas 1, kertas 2, 11. Question 11. We see how the question answer. 11. 2 more than 1, 2 more than 1, 2 more than 1. Okay. Or 2 more than 1, 2 more than 1, 2 more than 1. Okay, no problem. Now, angle increase, fx increase. Angle increase, acceleration increase. It should be the same lah. All right. The greater you can use increase, up to you. So this one format. Okay. So W P R theta. All right. Or this one, either one will do. So I just do one only. I didn't do both. Right. Now we see how the mark is given as 4. Label, draw and label, correct the line. Draw and label, correct the line. Okay. Mark 1. Draw and label, correct for W. W 1 mark. Okay, sorry. W 1 mark. Alright. R 1 mark. Mark the direction correct about the W and R. The direction correct. 1 more mark. 3 mark. Mark 3. M3 is mark 3. And then alpha, you don't put in. No mark. You put in, you got 1 more mark, 4 mark. So I got everything in. So if you forget to put the alpha, so you get 3 mark. So all the direction correct, you get. But why the P no mark? I don't get it. Why P no mark? W only, R only. W and R. Mark the correct direction of W and R. P no need. So lucky, if your P put this direction, mean you still get full mark. Funny, but I think there should be W and R and P all must be correct lah. Okay. Okay. This one 10 marks. Oh, is it? I don't know. Yeah lah, Thank you. P is given in the diagram. Yeah, you are right. You are right. Yeah, you're right. Okay. Question number 10. Question D. 11.4 shows a large number of vehicles using the bridge during the peak hour. Use the appropriate physics concepts, suggest a modification to the brick structure so that it can be safer. Right? Characteristic of cable, tower, and pillar. Right? We look at where is the cable. Cable is here. Alright, this cable. So tower is here. This tower is here. Pillar is at here. Alright. So they give 3 only. Alright, characteristics. Okay. Now, I don't know. I don't know. So this one you have to answer into this way. I do it fast. I show you characteristics and reason. Okay. Now, I want to show you this is your mistake that you have done. Okay, I show you. Because of this kind of question, like, you use pillar made of concrete. Pillar made from the concrete or not concrete, or maybe you got other better one. So you better don't use concrete. Don't use a specific. If they need steel, if they need iron, they need steel inside. How? So you don't put it. It must be 100% concrete. Or how many percent concrete? Or what? Concrete only. No need sand. No need other. You just need concrete. No need water. No need. Or what? So you don't use it. So I'll prefer you to say strong pillar made from strong material. Okay. And then maximum tension. What is mean by maximum tension of the cable? Have to be maximum. My tali only like 2 Newton only. Maximum? Yeah, I use maximum one. My rubber band 2 Newton only. So maximum mean highest. You have to use the word of high. Cannot use maximum. This is a common mistake made by the student. Right? Thick cable. Thick cable, it is mean by it is strong. Thick is strong. Not necessary. Not necessary. You better use the word of strong. Strong is very, very good answer. Now, strong and hard, two different things. Your glass, strong or not? Not strong. Easily break. Hard or not? Hard. It is not strong. You better use the word of strong. Okay? So this is a common mistake made by the student. So I'll use strong cable. Right? So why? We stain high tension. Right? Strong cable, we stand high tension. Now, and then, now I want to ask you, if I put the cable like that, in here, another one, let's say here, the cable like that. So it is strong or not? So I think had to be this way. So it will not break. It cannot be what, too small angle here. It has to be bigger angle here. So for me, the tension have to be for me lah. How should I write? Wider base area. Tension, right? Cable with wider base area. Right. So more stable. More stable. So I talked about cable already. Cable characteristics, so I put more. Right, put more. Okay. Tower. This tower, I think it have to be high. High tower. So if the tower it is like so short, can it tahan? Cannot, right? So high tower. High tower. High tower. I don't know what else. So pillar, strong pillar. Strong pillar, not break easily. Yeah. What else? 1, 2, 3, 4, not enough. Strong tower. High pillar. Cable, I got 2. Pillar. Strong pillar. So I don't know what else. High tower. So can increase the area of the cable. Increase the base area of the cable. Or you can increase the tension of the cable. Also can, I think. So I don't know what else. So we look at the answer. Now you see the answer is cable with strong cable. Yeah, I got it. Right. Not brass, not break easily. Okay. Concrete, strong pillar. Right. Withstand more force. Uh, strong cable. Why strong pillar, strong cable, strong cable? Oh, this one is BM. Menara is tower. Tower should be strong tower lah. They write it wrongly. Menara keluli. Menara kuat. Menara is tower ba. Tower. So they said cable. Right. Should be strong strong tower. Okay. Withstand more force. Okay. Oh, more number of cable. You see, I didn't put in. I don't have this. Okay. High tension of cable. Yeah. Big force. High tension I got. High tension. Oh, high tension I didn't put in. Oh, yeah, my mistake. So height of the pillar, it is high. So avoid water spill on the bridge. Okay. Diameter of the pillar big. Stable. More pillar. This is all the marks. So I didn't put in more pillar. Okay. So I screenshot this one as the answer for you. I screenshot the answer. I make it smaller. I screenshot. They originally Bangkok sikit Not my fault How undo. I add in another patch, okay? Oh, no. Not like that. File. Edit. Insert page. Insert page. Okay. Oh, wrong. Not this one. Undo. Not here. What am I doing? Insert page. Insert. Where is the insert? Edit. Insert page. Here. Okay. Here. I put in this for you. And then I put in this for you. Wait. Yeah, correct. This one no need lah. This one nothing here. Okay, this is the answer. Right, this is the answer. Right, you can see lah. Right, this is the answer. So for me, how many marks do I get? 1, strong cable, withstand high tension. Wider base area don't have. No, don't have. Not, I don't want to mark myself correct. No. Right. High tower, don't have. Increased, no. Strong pillar got. So I only got 4 marks. Because I'm lazy. I'm lazy. I can, if I think more, I can write more one. Right. More number. So here, more number. Okay. So you see how many marks do they have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you only need to do 5 and 5. Right? Only need to do 10 on. Only 10. So strong, you can get 3 already. Tower, I didn't write. Okay. This is what we have. Okay. Question? Alright, I know time's up already. Still got a few questions, so I am not going to do it here. If you do it, I'll mark for you. Right? Like you see, I'll mark for you lah. Right? But some of the question I will accidentally mark it wrong. I'm sorry. But you do it, you see the pattern, it is the same one. So I didn't do it. I don't do it. I tell you, I got not enough time to do it. So next week we are going to do the next one. Elasticity. Right, 1.4. Right. I am going to stop here. I'll see you next week. I hope you can help me to press the like button. Thank you. Thank you. Right. I'm going to stop here. I'll see you. Bye bye. Good night. Bye bye.